So let's look at today's code sample. We're going to talk about how to make things look like they are floating in water. Okay, and hold on, I'm going to do the screen share, and I think I've actually worked this out to where I'm going to do. Oh, hold on, let me move this over. I'm going to do a desktop share where I share the whole thing. Oh, well, look at this.
What's the matter?
I don't know. Hold on. I'm having desktop. There you go. Desktop 2. And the reason for that is because if you share just wow, look at that. That's awesome. If you share just a wow, did it go away? Yeah. If you share just the simulator, then every time the simulator refreshes, the screen sharing goes off. Yeah, you lose it. You lose it. So I figure if I just share the entire desktop and then move the code around and get the hold on. So just bear with me. I'm going to move the simulator over there. I'm going to move the code around a little bit, and then hopefully get us all in view, and then we can make changes. Because I know Ed's got a gazillion changes he wants to make.
So this is a sample code that Corona made?
No. Okay, so thanks for that, for setting me up there. No, this actually comes from Adam at insert code or insert.
Oh, okay.
Yeah, insertcode.co.uk, which is actually, I think if you go to his website now, it's insertco.de, right? So insert code with a .de domain, and it was down for a while. The website was down for a while, and apparently the domain name had expired, and there was all kind of other things going on, right? And so the code kind of fell out of circulation, but the website's back up now. So if you go to the website, it's all there. This example is there as well. So I talked with Adam this weekend, and he said he's going to be putting up some and things like that. Go there and check it out. I'm going to put that link in the chat. The other thing is Ed has posted this. Yeah, there you go. Thanks, Ed. So the other thing is, Ed, and put that in the chat. The other thing is, Ed's posted this on GitHub, which we will put that link in the show notes as well, and share that out because it has a couple of different examples, a couple of different variations. So okay, so let's walk through this though, and see how this is all there. So basically, this got a little MIT license, so you can kind of use the code as you see fit. And so, okay, so starting at the top here, the very first thing that we do, and Ed, jump in if you have anything to say here, because I know you've reviewed the code and made notes. But basically, okay, so as per standard here, we kind of get rid of the display, the status bar, because it's ugly and we don't need it most of the time. And then we bring in our physics. I'm scrolling around here between 2 or 3 screens. Hold on. Lost my cursor. Okay, awesome. I completely lost my cursor. I don't know where it went. I think my mouse might have died. Okay, so we bring in our physics engine and start it up, and then we set gravity for the entire world because we don't want it just to default gravity. We want to actually set it, and I think this is basically we're setting it to pull everything down, not just. I mean, you can pull everything up with gravity, but here he's actually set a very specific gravity. I didn't
40.
play with that. I didn't play with that. Did you play? Did anybody play with that?
It should be 9.8. That's like the default, I think.
Yeah, that's the default, but he's okay. We'll play with that a little more later. But he's kind of reset gravity, and I've got see there. See how everything kind of falls in. It's the frame.
Yeah.
The frame rate's a little wonky here on Google Plus, but if I set it to increase the gravity, everything kind of. Let's see if we do that again. Hold on. Let's do that. Hold on. Let's do that again. My mouse went dead right here in the middle of the show. Awesome. Let's refresh. It doesn't seem to have. It doesn't seem to have too much difference.
What'd you put it at?
I put 90 on there. I guess that's maybe not a different. That's a little bit of a difference.
Definitely different.
Yeah, so whenever things fall into the water, they either fall in deep or they fall in shallow. Let's just say that. So based on that gravity that he's set. So, okay, so that's enough about that. and then the other thing that he does is he goes in and he gets the gravity for the x and the y, which we'll look at in a little bit here. And he sets a few forward references, so these are variables that he's going to work with at some point, but he wants to go ahead and define. I like defining everything in one place. I like the way this is done. You know, kind of putting it all here. That way I can come back later and say, okay, well, if I need to add another variable, I go back up to the top of my code and I add it as a forward reference and I use it later. So sometimes that's for reasons like you're going to need it in advance, and sometimes I think it's just for cleanliness. I don't know. What do you guys think?
Yeah, I do that too.
You do that? You kind of group all your variables up the top?
Yeah, like the display.content with, like all that. It just saves you so much time.
Yeah, it's easier to. Sometimes, I know you can do search and replace and find your variables and stuff, but sometimes it's just easier just to scroll back up to the top of the screen and just add a new variable or find a variable if you need it or whatever. I don't know. I like it. Keeps everything organized. Okay, so. But what he's doing here, yeah, so he's grabbing the screen width and height. He's also setting up some forward variables for our boundaries, which we're going to have, we've got to keep our water on the screen and our blocks on the screen. And then he's got a liquid level, which I don't remember what that does, but he goes ahead and declares that here. He sets up his density for the liquid, the number of boxes, and these are all variables, so they can go back and change them later. So if you wanted to have 10 boxes, you could. So I think that's a good idea, of course, always to set your variables someplace you can change them. That way you don't have to go picking through your code to make updates. And then he's got the number of the box size. So each box could be, each box could be bigger, right? So now we could have just bigger boxes.
Charles, I wanted to talk to the gravity thing for a sec.
Okay, yeah, go back to that. Where at?
Okay, so before you get into it, you'll probably see it when you're doing the code here, but unless I'm pretty sure I'm correct here. So the way this demo works is Box 2D doesn't like objects with bodies that are colliding to interpenetrate. So okay. I think
I don't even know what that means.
So overlap. It doesn't want them to overlap.
Oh, overlap. Okay, thank you.
Sorry. And so by adding raising the gravity, basically all it does is overcome the natural tendency of the object to attempt to stop overlapping.
So you're talking about right here?
Yeah. So you get, when you raise your gravity to like 100, you get a lot higher penetration when you drop the blocks.
Oh, if you drop it to 100.
Yeah.
You raise it to 100.
Raise it to 100.
Yeah, it's gonna be hard to see here.
Smaller too, but okay. Anyway, I'll let you continue. Sorry.
No, that's okay. Let's see here. Yeah, I got you. So let's make the blocks. It may be hard to see, but let's see. Oh yeah, it's definitely gonna be hard to see. Okay, but the idea there is what you're saying is that we want to keep the blocks separate from. I get it. Okay, so let's go back to this. What was our block size? 40. Okay. Actually, I'm gonna bump it up. I don't know how it's gonna affect the overall thing, but let's bump it up. It makes it easy.
Yeah, unfortunately, it doesn't come through well on the Google Plus because it doesn't record at a high enough frame rate to see it.
Yeah, exactly. When you download the code for this, you'll see that everything, even the what probably doesn't even show up is the fact that it's bobbing. All the objects in the water are actually bobbing.
Yeah, you can just barely see that.
Yeah, let's see. Let's bump. I'll tell you what I'll do too is let's just increase the size of the simulator. Whoa!
There we go. And sing? You're going to sing too? Awesome.
Yeah, exactly. Well, I'll tell you, you got to have sound effects for all these tutorials.
Oh.
Okay, can you kind of see that? It's kind of like little ice cubes to kind of dancing in the water.
Yeah, I can see it.
Okay. Well, that's all that's important. Okay, so we set our boundaries. I don't know what happens. I didn't try to, as I was picking this code apart, I didn't try to take the boundaries out. Does anybody know what happens if you take out the boundaries? Does the water run off the?
I didn't play with this demo nearly as much as the next one because the next implementation of this was so sexy to me, and I mean that the code was like, wow, why didn't I think of that?
Yeah, we know what you mean, sicko. Okay, so
Interesting day.
anyway, so we set a ground and we set a ceiling, and we set a left and right wall, which is pretty standard anytime that you don't want your. I think mainly it comes from the fact we don't want our boxes falling off the edge, right? I mean, we could make these boxes big enough they'd actually crowd each other out and push each other off the stage and fall off the edge. So we don't want that. And then we set them all to static, so that again they won't be bouncing around necessarily, or they won't fall off the stage. They'll just be there. Okay, so we do that, and then we create this group. So we create a boxes group. We're going to put each of our boxes into, and so now we've got kind of our main stage, and then we've got this boxes group on the screen, which we can't see it, but we're going to add boxes to it. So in our add box function, we're going to add boxes to our boxes group, which is fairly confusing. But what we do is we create that add box function first, because in the next few lines here, 95 to 98, we're actually going to use it. So what we do is we flip through and we create boxes that go into those groups. So essentially, whatever our variable was, I think we said 5 boxes, right? We are going to flip through 5 times, and we're going to add boxes to our group. Nice. And so we're going to create a new rect. So we're just going to create some basic geometric shapes. In this case, we're going to create some squares and pass in our box size and that sort of thing. And we're going to go in and create 5 different boxes and stick them into this group. So we randomly set the X so that they don't all kind of appear in the same place, and then we set the area, the density, and the mass for that box, which is actually just is area density and mass. Is that actually a property of NewRect, or is that something that we're just creating on the fly? Does anybody remember? I didn't research that part.
Hold on.
I don't remember.
Okay, Ed's looking it up. So anyway, we're going to set those because we are going to use those later on in our calculations. But Ed's going to look up whether or not that's part of the NewRect, or whether or not I think we're just setting them as.
Actually, this is I think what I spoke to a week or two ago, which is about a year ago, Box2D's implementation in Corona. I don't know about worldwide, but in Corona did not have a mass attribute. And so, it was probably out there, but the key is if you wanted to do calculations where you applied a force to an object and you wanted to be consistent across different sizes, you had to figure out your own masses so you could do the appropriate calculation to apply the proper force. So what he's doing here, it looks like an adaptation to an older version of Corona where he did not have a mass value, because today Box2D implemented in Corona does have a mass attribute.
Okay.
So long story short, this is something he probably did to overcome something that did not exist previously.
Gotcha. Okay. All right. Well, we use those calculations later on, so they are important. And then he randomly sets the fill color on them, so they just show up as different colors. And then he adds a adds a physics body to each one of these so that they'll interact with each other, which I don't know if we showed this before, but you can actually pick these guys up and spin them around, and you can stack them on top of each other, and they kind of interact with each other. It's a little weird because I made the boxes really big, but they won't, just like a real physical world object, they won't stay balanced on top of each other. They kind of float apart. But we flip through, and we do that each time. So we've add box has been flipped through 5 times, and so we've added 5 boxes to our boxes group, and then he comes in and creates a liquid. So this isn't really boxes in water. This is just sort of a special effect, right? We're kind of fudging it. So he creates, again, another new rect, which is our background here, our little blue water type background. Sets the fill color on it, kind of gives it translucency with the alpha, and then sets the reference point to the top center reference point, which is essentially going to be our water line right up here across the top. And then makes it to where it takes the height and width and kind of splits it and says, okay, we're going to do half the screen here. You know, our water's going to fill half the screen, and that's really it. I mean, it's just kind of a special effect, right?
Hey, Charles.
Yeah.
I need to redact the statement here. See, he did not even use the body premise on this one. So,
okay.
Again, Box2D doesn't like to have two bodies that overlap. He didn't use that. He's actually using an enter frame method, where every frame, each of the boxes you've got there, the 5 boxes, is checking against where it currently is, and if it's below the top of the water level, it applies a force.
Yeah. Well, we'll get to that in just a second. Exactly.
So my mistake on that one. I'm sorry. It's a little bit different from the next example.
Okay. Let me zoom out a little bit here so we can. What was that?
Okay.
We got crickets. Okay. That's not bugs in our code. That's just crickets. Okay, so the next thing we're going to do is we're going to do the drag body. So we're going to apply an effect or a touch event for each one of these boxes. So he goes ahead and defines that function first, because down here in 137 through 140, we're going to use the code, right? So we're going to flip through boxes, which is again is our group, for however many items are in the boxes group. We're going to flip through that number of times, right? So we put 5 boxes into the boxes group, so that means there's 5 children of that group. And then what we're going to do is we're going to flip through. We're going to add an event listener, a touch event listener, to each one of those boxes, and it's going to do that with the drag body function. So if we go back up to look at what the drag body function does, it passes in this variable is the event, whatever happened, whatever was touched, rather. That's passing it in as an event, and then we're going to go ahead and grab that out and say, okay, well, which object was touched as part of that event? And so we're going to find that using the event target. What phase is that in? So we're going to say, am I touching, am I moving, or have I released the object? So we're going to figure that out. And then the other thing that's interesting here is it's actually figuring out where it is on the stage. And I actually had to go look this up to figure out exactly what it was doing. But essentially, when you start up your project, the blank canvas, if you will, the blank screen there is just sort of your current stage. It's the default stage. And then when you put things on it and do touch events, you have to figure out where those objects are, right? Because they're not just on the stage, they're in a group that's on the stage. So by getting the current stage, you're able to figure out where things are and how to interact with them. I think that's probably the best way I could describe it, unless you have a different way of explaining it.
I have no words of wisdom for you.
Okay. So that's basically it. We're reaching into. I like to think of it as we're reaching into the group, and we are touching one of the boxes in the group, and Corona knows that we're doing that because we do this get current stage, and then we use it later on. So when on our began phase, we've just touched the object. We're going to set the focus to that stage. Okay, we're going to set the focus to that body within the stage, and and then we're going to create a joint, a physics joint, and we're actually going to create a touch joint. Let me go over here and get my note. I have a note on this. Hold on, because if you look at the documentation, it says the Corona docs. It says that the touch joints. The touch joint is based on the Box2D mouse joint, and it connects a single object to the current position of an on-screen touch. So basically, anywhere that you've touched, you can set a joint for that specific area. So like if I grab it up here in the corner, the right-hand corner of this box, that's where I've touched that object.
Hey,
So
Charles,
rather than
you can demonstrate this a little better by turning on hybrid rendering mode.
okay, yeah, that's okay. That's a good idea.
Go all the way
Yeah,
to the
so
top.
if we don't have that, let's see here, physics dot mode, right?
Set draw mode. Yep. And then pass it the string hybrid. No.
Hybrid.
Yep. Lowercase hybrid.
Oh,
It's helping you out too much.
I know it.
Now do your dragging thing, and you should see a little dragging, a little line from where you drag.
Is it it?
Okay, reload your app and show us the dragging.
No. It doesn't look like it turned it
No,
on.
go ahead. Well, that's strange. It doesn't look like. Go ahead and give it a try, anyways.
What do you mean?
You just click on one of the boxes and drag. Why is it not coming on?
I don't know.
Oh, I see. No, I don't see it. Thought maybe you'd spelled something wrong.
I don't know if he's going to get the draw point, but he is getting the actual hybrid mode because you see the outline of the squares a little better because it's actually showing all the physics that's applied to the square.
That's weird because it works for me.
Okay, well, that's all right.
Of course it does.
That's okay. I've probably got something wonky there, but let's just keep going. Okay, yeah. So the main point, like, if I grab down here in the bottom left corner of this box and pick it up, my joint is, see, it's right there. Oh, you can almost see it if you drag it real quick.
Yeah. Yeah. Okay.
Yeah, it's there. It's there. It's actually just attached to wherever I put my mouse on that box, right? As opposed to, like, if I picked it up right smack, if I picked up the box without this, it'd be like I'm just picking the box up and moving it up and down. I could move it, but here, I mean, it's attached to whatever point in that object that I click or touch. Okay, so it interacts or is affected by physics according to that. Okay, so it gives it kind of the ragdoll effect almost, without actually creating all the joints for a ragdoll. So that's when it began. When it moves, it's actually just reassigning the coordinates for that joint. So wherever that moves, wherever I've touched it and move it around, it's moving that touch joint around, so that everything kind of stays.
Yeah, unfortunately you can't see it here. Basically, it's creating a temporary joint where one end is attached to the box and the other end is to your cursor, and so it tries to follow your cursor around.
Yeah, exactly. And then on the ended, we're basically we've stopped touching it, we've let go of it. Now we need to down here at the bottom, we need to set the body to nil. We need to set remove focus from the stage and from the object. We need to remove the touch joint because to free up resources and stuff like that. We need to set it to nil. So every time that we touch an object, we're going through these 3 phases. Okay. And so that allows us to. That's simply just to allow us to drag the objects around on the screen. We don't have to do that. If you don't want to drag the objects for some reason, you could just leave this part out. But it's an interesting, it's a nice example of that function. Okay, functionality. So let me see here. This is so the real beauty of all this was where the magic happens is in float. And let me actually get rid of these comments here, just so that we can crunch. Because what happens like you were saying, Ed, this is all happening. If we scroll down to the bottom, this is all happening on an inner frame. So every 30 frames a second or 60 frames a second, whatever we've got it configured for, it's going to call the float function and basically adjust the boxes. So what's really happening is the boxes are being pulled down initially by gravity, and then they're being pushed up and pulled down over and over and over again, which simulates this effect that makes them look like they're floating in water or floating in a liquid. So the first thing that we do on our float, again, this is being called every 30 frames a second or 60 frames a second, however we have it configured, is that we flip through the group, which is the box's group. We find out how many objects it has in it. And then we go through and we look at each one of those boxes. And we say, okay, for this box, I want to set the y. Let's see, what is it doing here? If okay, yeah, it's applying the forces to the box, right? So it's saying, is my location of my box greater than or equal to basically kind of like my water line, right? And if it is, then it's coming in here and it's doing some calculations. So in the beginning, it's saying, okay, our submerged percent, how much we're going to be submerged, is calculated. And then the next thing he does is he sets a default and says, okay, I don't ever want you to be more than 100% submerged, right? Because that doesn't make any sense. You can't be more than 100% of something. So he goes ahead and sets a default for that, just in case. And then he comes in and says, okay, if that submerged is greater than 40, so this is just an arbitrary number, right? This is just anything, like he said, okay, I want like 40% of the box to be submerged. If it checks for that, and if it's greater than 40%, then it's going to push the box up a little bit, right? Because the box, if I go over here and pull the box down, now the box is like, let's say like 2 or 3, 5% maybe submerged. If I let it go, then the code's going to push it back up. If I raise it above the water line, it's now 0% submerged, right? It's not submerged at all. Then the code's going to pull it down. So essentially what we're doing is we're saying if the submerged percent is greater than 40, then we're going to apply, which he's treating as a buoyancy force here. So he's looking at the mass of the box times the gravity. Remember, we got the gravity up at the top. And then we're going to apply some force to that. So we're essentially calculating how much force we're going to apply to the box, and then we're applying that force to the box here. So we're pushing it up. Let me see. Go back over. Note about that as well. The apply force. So on the apply force, you've got a couple of different variables going on. The first two things here are the x and the y of the force itself, and this next two are the body x and y, where you want to apply the force to. So essentially, we're calculating this y value here of how much we want to push the box up.
Right. The key point is they're pushing up. The code is pushing directly in the center of the box and only upward.
Yeah. So I could, if I wanted to, I could come in here and say 60% of the box, right? So now the box is, if you look at it, the box is actually sunk lower in the water line, right? Because now it's more submerged than before. So it's really easy to go in and just play with this. So if I wanted it to be like 20, now the box would sort of sit on top of the water, almost. So it would really depend on what you're trying to do as to how you want it to react. And the next thing it does here is it does some line dampening and some angular dampening, which I thought was interesting, because if you don't do linear, I'm sorry, I said line dampening. If you don't do linear dampening, it has a pretty interesting effect. Hold on, let me take this back down to like 80 for the box size.
It's a good size.
Yeah, and then let's go back down to linear dampening. So right now, when the boxes fall, they fall into the water and they bounce, they jiggle around a little bit, and they kind of come to rest, right? And then they're just kind of bobbing up and down like they're in water. But if you take and set the linear dampening to say 0 and save, then the box is like they bounce up and down which is here. Let's do one.
They fly out of the water.
Yeah, they actually fly. Like there you go. See those two on the left there? They're actually flying out of the water, and they just keep doing that. It's almost like there's no, because again they're not actually in water, so there's no real friction.
Right.
So they just kind of, it's almost like a perpetual motion machine. They just keep going up and down, up and down, up and down, because there's nothing to diminish that.
Well, you said the key word there. Linear damping is in essence, like air friction on the body.
Yeah. And the other part of that was the angular dampening. So let's take the linear dampening back, and then if you notice when I take these guys and move them around, actually let's take this back to 40%. When I move these guys around, if I grab a hold of one of these guys and kind of drag him, see how he doesn't really spin. Like as soon as I let go of him, it's like it's almost like the water has drag on it, so it doesn't free float, I guess you could say. Mm-hmm. If I go in and on the angular dampening and set that to 0, though, now there's like no friction. So the boxes will just continually spin.
Yeah, it looks wrong.
It looks wrong, yeah. It's cool. Yeah. So as I was going through this, I was like, well, these are some, I mean, as you play with this, it's really a water buoyancy example, but you could manipulate it to get any kind of effect that you want. So you could really have some fun with this. I mean, because these are squares, but they could be characters, they could be anything, right? So anyway, so it's
a key takeaway for people here who are listening, besides the just fun playing with this example, is playing with physics attributes can easily lead you to a game mechanic.
Yeah, very well said. Definitely. Okay, so then the other part of this, like I said, is pushing up. So or pushing down. So if our let's say, for example, our submerged percent was, then we're going to do this push down. So if our object is bobbing up in the water too far, then we're going to want to push it down. So that's basically it.
Mm-hmm.
And so so let's move. I want to show this other example.
Yeah, we better show the other one with the.
I know. Yeah, let me see this. Hold on, I have it here. So that's the first example. This next example, I think, is I think it was Matthew Webster, who is a Corona ambassador. I think he came up with this. And we're not going to walk through the code, but we do want to talk about some of the key points.
Yeah.
Do you?
I can talk to it if you want. Sure,
go ahead.
All right. So unlike the last example, where there was a single body representing the water, and in that example, we basically measured where the block was and applied a force if it got below that point. In this case, each of the little dots is a physics body, but instead of having it collide with the big box and have a response, what they've done is set each of these bodies to be a sensor. So basically in Corona, actually Box 2D, if two bodies collide, but one of the bodies is a sensor, then the colliding bodies are allowed to pass through each other without any physical response. The beauty of this example is what the author has done is said, okay, I've got two bodies colliding, one of them is a sensor, and every time a sensor sees that it's got a collision, it applies a little tiny bit of force to the block that collided with it. So in other words, the big block, like the one you've got bobbing there, is bobbing up and down, and it's hitting all these little tiny bodies that you can see, the little blocks. And every block that it hits applies a little tiny bit of force, pushing the block back up a little bit. And a slight difference here is in the last example, the force was applied at the very center of the floating block. That's not true in this case. Each of the little blocks says, where am I, and applies a force at that very position on the big block. So a little bit on the right, a little bit on the left, a little bit on the bottom, which is what gives you this nice sort of floating and drifting effect. Yeah, could you restart your simulator? And then
you can almost see the dots. Yeah, when you look at the code in real time, or the simulator in real time, you can actually see the dots turn different colors.
Yeah, unfortunately, it's harder to see with the.
Yeah, but when
Yeah.
we'll put a link in the show description so people can go and download the code and play with it.
Although, you could easily modify this code to actually change the color of the blocks to show you which ones have got a collision going.
Yeah, I was playing with that before we got.
Another thing you could do is to see the effect of the application of force. Is you could modify this. All the code's available on GitHub. For anybody listening, you should take this code just to see what it does, and modify the algorithm, the loop that creates these little blocks, and use like math random and say math random 1 to 5, and every time it's equal to a 3, don't make the block. So what you'll get is like this weird sea of blocks where there's gaps. And then when the block falls down, it'll be real clear when there is and is not a force being applied.
Oh, cool.
Yeah, because it'll act really strange. It won't look right anymore, but it'll bring out the essence of I got forces being applied over here, but no force on the other side.
Now you put several variations of the code out there on GitHub. Does one of them have that?
Explanation on that. So this one on GitHub is called Buoyancy 2.
Okay.
But one small flaw in this example is it was written to work with 30 frames a second explicitly, which is cool. But with the physics in Box 2D, you always have to consider how often you're applying force per second, because if you set the frame rate up to 60, the demo fails, and the basically what happens is the block sinks to the bottom of the water.
Okay.
So example 2.1 out on GitHub shows that and how that works. And then example 3 adds some code to fix that. So regardless of what the actual frame rate is, it always has a consistent behavior.
Gotcha. Well, I was playing with this code, the actual simulator, before we got on the call, and I don't know if you noticed, but just to kind of further illustrate the fact that these sensors are interacting with the block, if you create a block, because you can just touch and grab on the screen there, if you create a block in between the sensors and let it go, it'll fall all the way down because it's not actually floating.
Yeah,
but if
not until it hits something.
But if it touches one of them, man, it goes nuts. Look at it.
Yeah, that exactly demonstrates what's going on. It's no interaction until it actually hits one of those little blocks, which is applying a force to it.
Which I just thought I was like, this is really fun. I mean, this makes you just want to play with it.
The last example was great, but I love the ingenuity of this because you can use this. Great, it's water. We get the idea, but you can use this mechanic of a sensor colliding, applying a force with all kinds of game ideas.
Yeah. This is the exploding butter is what I call it.
I can imagine having like a shooting game, like a tunnel flyer, where you've got force fields in some places that push on your ship and things like that. Or fans. You could use this to create a fake fan effect that blows things up as they go by.
I'm laughing because you're totally into the physics thing of it, and all I see is exploding butter.
Mr. Exploding Butter over there. Okay.
That's pretty cool. And let's show the last one. Let's show that one last one before we leave. I know we're a little bit over time, so I apologize. But
we showed that on the last show, I think.
I know, but I kind of want to show it again. It's so cool. Yeah. So here's the ripple one. So it looks like it's falling into water and then causing ripples. So this is another one that I want to be sure to post a link to on the show notes because I'm not sure what I would use it for. I mean, at the moment, but it's definitely a nice little piece of code that you'd want to hang on to. And then, as you demonstrated last time, you can grab the screen and you can create almost like a music, sound wave type effect there or whatever. So again, I'm not sure exactly what you would use that for at the moment, but it's cool.
Yeah, I love these examples.
Yeah, and I think for anybody who didn't see the last week's show, I think you said that each one of those lines across the top, each one of those points rather across the top, is being calculated on the fly. So so that's how it gets its relationship from one dot to the next. So it's calculating its relationship on either side, which is very cool. Real nerdy and very cool.
Yes, nerdy. Thank you. Not geeky, nerdy.
Geeky. Well, geek is chic. Nerdy's just real. All right, so let's turn off the screen sharing.
Yeah, I'm including one more version. I'll check it out on GitHub.
Okay.
Put it on GitHub, but it does this. Basically, what I was talking about, it randomly does not create some of the sensors, so you get this like patchy behavior.
Yeah.
And you can play with it to see how having sensors does or does not affect the force. See, like the force is no longer even, so every time it hits a group, that edge goes up. It's a little bit hard to see in the demo here, but I think people will get it.
And doesn't look like it's enough to keep the block from falling.
Yeah, also it's not enough because, yes, this example is extremely sensitive to the amount of force, which is each little dot has to apply just its own part. Oh, we forgot to mention that. Multiple calls to apply force in Corona / Box2D is additive. So every frame, if you call it 100 times, all those forces, so let's say I apply force 1 and I call it 100 times per frame, that's the same as applying force 100 just one time.